Monday, August 24 in 2026. Welcome back. And today we are tracking a powerful earthquake that struck in one of the most remote and least populated corners of the entire planet, a magnitude 6.2 earthquake that ripped through the South Atlantic Ocean early this morning, just 90 kilometers from the icy edge of Antarctica. This earthquake struck in the pre-dawn hours, far from any city, far from any major population center, and far from the kind of headlines that usually accompany an earthquake of this magnitude. But the fact that almost nobody felt it doesn't mean it doesn't matter. This earthquake occurred in one of the most seismically fascinating and genuinely underappreciated regions on Earth, a stretch of ocean where an entire hidden tectonic plate grinds and twists beneath the waves, producing earthquakes with a regularity that few people outside the seismology community ever hear about. And by the end of this video, you are going to understand exactly what happened this morning in the Scotia Sea, why this particular stretch of the South Atlantic produces earthquakes at all, what makes this region's tectonic setup so genuinely unusual compared to almost anywhere else on the planet, how this event fits into the broader picture of what has already been one of the most seismically active years the world has recorded in quite some time, and why remote earthquakes like this one, even ones that hurt no one, still matter for how we understand the planet we live on. Let's start with exactly what happened this morning, because the specific details, even for a remote earthquake like this one, matter for understanding the bigger picture. According to seismic monitoring data, a magnitude 6.2 earthquake struck at approximately 5:22 in the early morning hours local time, which corresponds to Greenwich Mean Time minus 3 hours, on Saturday, August 22nd, 2026. The epicenter was located in the South Atlantic Ocean, roughly 90 kilometers, about 56 miles, from the coast of Antarctica, placing this earthquake in what's known as the Scotia Sea, a body of water sandwiched between the southernmost tip of South America and the northern edge of the Antarctic Peninsula. This is genuinely one of the most isolated stretches of ocean on Earth. There is no significant population anywhere near the epicenter, no coastal city, no fishing village, nothing but open water, scattered ice, and a handful of remote research stations operated by various countries hundreds of kilometers away. As a result, monitoring agencies confirmed that the earthquake was not felt, or at least not reported felt, by anyone, which is exactly what you would expect for an earthquake of this magnitude occurring in a location this remote. The precise depth of the earthquake could not be immediately determined by monitoring networks in the hours following the event, though seismologists generally assume it occurred at a relatively shallow depth based on the typical behavior of earthquakes in this specific tectonic setting. This particular earthquake was significant enough to register as the strongest earthquake recorded anywhere on the planet on this specific day, out of more than 1,000 earthquakes detected globally within the same 24-hour window. A reminder of just how constantly active our planet's crust actually is, even on days when nothing makes it into the news. It's worth pausing here to explain just how routine and yet how easy to overlook this kind of number really is. Every single day, somewhere on Earth, more than 1,000 earthquakes occur, most of them far too small to be felt by anyone, registering only on the sensitive instruments that seismologists around the world use to continuously monitor the planet's crust. Within any given week, that number climbs into the tens of thousands. The vast majority of these events happen in places exactly like the Scotia Sea, along oceanic plate boundaries deep beneath remote mountain ranges, or scattered across sparsely populated stretches of the Earth's crust where there simply isn't anyone around to notice the ground moving. This morning's magnitude 6.2 earthquake stands out only because of its relative size, large enough to be classified by monitoring services as a very strong earthquake, a term generally reserved for events in the magnitude 6 to 6. 9 range, which represent genuinely significant releases of tectonic energy, regardless of where on the planet they happen to occur. To understand why an earthquake like this happens in the middle of the South Atlantic Ocean, thousands of kilometers from the nearest major city, you have to understand one of the most unusual and least discussed tectonic features on the entire planet, a small, independent tectonic plate called the Scotia Plate. Most people, even those with a general interest in geology, have never heard of the Scotia Plate, largely because it sits in such a remote part of the world and doesn't produce the kind of catastrophic, headline-grabbing earthquakes that strike heavily populated regions like Indonesia, Japan, or the west coast of South America. But the Scotia Plate is genuinely one of the more geologically interesting structures on Earth, precisely because of how it came to exist in the first place. The Scotia Plate is a relatively small oceanic plate wedged between the much larger South American plate to the north and west, and the Antarctic plate to the south. It essentially formed as the gap between South America and Antarctica gradually widened over tens of millions of years, a process connected to the broader breakup of the ancient supercontinent Gondwana and the eventual opening of the Drake Passage, the stretch of open ocean that now separates South America from Antarctica and allows the Antarctic circumpolar current to flow uninterrupted around the entire southern polar region. As that gap widened, a new independent plate formed to fill the space, bounded on nearly all sides by other major tectonic plates, creating a genuinely unique and complex zone of deformation that geologists have spent decades trying to fully map and understand. The boundaries of the Scotia Plate are seismically active along almost their entire length, but in very different ways depending on which edge of the plate you're looking at. Along the western edge, near the southern tip of South America, the boundary is dominated by strike-slip motion, plates grinding sideways past one another, similar in mechanical behavior to California's San Andreas Fault, though on a much smaller and less studied scale. Along the eastern edge, however, near where this morning's earthquake actually occurred, the tectonic setting is dramatically different. Here, in the region known as the South Sandwich Subduction Zone, the South American Plate is actively being forced downward and westward beneath the smaller South Sandwich microplate, a subduction system that produces genuine, sometimes quite powerful earthquakes on a fairly regular basis. The South Sandwich Islands themselves, a chain of small, volcanic, uninhabited islands scattered along this boundary, sit directly above one of the most active and least monitored subduction zones anywhere in the southern hemisphere. And this region has a long, well-documented history of producing earthquakes in the magnitude 5, 6, and occasionally even 7 range with genuine regularity, almost entirely without ever making international news, simply because there's essentially nobody there to be affected by them. This morning's magnitude 6, 2 earthquake fits comfortably within that established pattern. Earthquake monitoring records for the South Atlantic region show a consistent, ongoing background rate of significant seismic activity throughout this year alone. Just months earlier, in January of 2026, a magnitude 6, 0 to 6. 3 earthquake, depending on which monitoring agency's recalculated figures you reference, struck in almost the exact same general area, near South Georgia and the South Sandwich Islands, at a depth of roughly 68 kilometers. In February, a magnitude 5. 4 earthquakes struck further north along the southern mid-Atlantic ridge. In April, a magnitude 5. 2 earthquakes struck along the southern mid-Atlantic ridge as well. In July, the region produced a magnitude 5. A 0 event followed just a day later by a magnitude 4. 8 earthquake nearby, and earlier that same month, a deeper magnitude 5. 2 earthquakes struck in the South Sandwich Islands region at a depth of more than 183 kilometers, indicating activity occurring not just along the shallow subduction interface, but deep within the descending slab itself, similar in mechanism to the deep interslab earthquakes that occur beneath other major subduction zones around the world. And in June, a substantial magnitude 6. 6 earthquake struck along the central mid-Atlantic ridge, a completely different tectonic feature further north, but still broadly within the same general South Atlantic seismic zone that monitoring agencies track together as a region. Across the past year alone, this stretch of the South Atlantic has recorded roughly 49 earthquakes, according to long-term tracking services, an average pace of activity that places it firmly among the more consistently active oceanic regions on the planet, even though almost none of it ever reaches public attention. It's worth taking a moment to explain exactly why the South Sandwich Subduction Zone behaves the way it does, because it's genuinely one of the more scientifically interesting subduction systems on Earth. Most of the world's most famous and most destructive subduction zones, places like the Cascadia Zone off the Pacific Northwest, the Japan Trench, or the Sunda Megathrust beneath Indonesia, involve a large oceanic plate being forced beneath a much larger continental plate, generating enormous megathrust earthquakes capable of magnitude 8 or even magnitude 9. The South Sandwich Subduction Zone is structured somewhat differently. Here, it is the South American Plate itself being subducted beneath the small, actively spreading South Sandwich microplate, a considerably smaller overriding plate than the massive continental blocks found at most other major subduction zones around the world. This unusual configuration, a large plate diving beneath a small one, rather than the more typical arrangement of a small oceanic plate diving beneath a large continental one, is part of what makes the Scotia Sea such a genuinely unusual natural laboratory for studying subduction zone mechanics. The South Sandwich microplate itself is also actively spreading along its eastern edge, meaning new oceanic crust is continuously being generated there, even as older crust is being consumed along the subduction zone to the west, creating a tightly compressed, geologically busy zone where multiple different types of plate boundary processes are all occurring within a remarkably small geographic area. This kind of complex, multi-process tectonic environment tends to produce a steady, ongoing background rate of moderate earthquakes, generally in the magnitude 5 to 6 range, punctuated occasionally by larger events, rather than the kind of rare but catastrophic megathrust earthquakes associated with the world's largest subduction zones. That said, the region is not entirely without historical significance. Earthquakes in the magnitude 7 range have occurred along the South Sandwich Subduction Zone in the past, and scientists studying this region continue to monitor it closely, in part because it offers a genuinely valuable comparative case study for understanding how subduction zones behave under different plate size and geometry conditions than the more heavily studied and more famous subduction zones elsewhere around the Pacific Ring of Fire. Understanding a smaller, structurally unusual subduction system like this one actually helps scientists build better, more complete models of how subduction zones in general behave. Models that can then be applied to improve hazard assessments for the much larger, more dangerous subduction zones that sit directly beneath major population centers elsewhere in the world. It's also worth placing this morning's earthquake within the broader context of what has already been an extraordinarily active year for seismic activity across the entire planet, because while this specific event in the remote South Atlantic didn't threaten anyone directly, it occurred against the backdrop of a global seismic pattern that scientists have been watching closely throughout 2025 and 2026. Researchers tracking cumulative global seismic energy release found that 2025 was one of the most seismically active years in modern recorded history, with total energy released by earthquakes of magnitude 5 or greater reaching levels close to triple what was recorded in 2021. A year that had already been considered highly active because of a cluster of 3 separate magnitude 8 or greater earthquakes. That elevated pattern has continued into 2026 without any meaningful sign of slowing down. Just this month alone, a magnitude 7.4 to 7.5 earthquake devastated Western Colombia, killing more than 300 people. A magnitude 7.7 earthquake struck Indonesia's Flores Island, killing dozens and triggering tsunami warnings across 4 provinces. A magnitude 6.9 deep focus earthquake struck North Sumatra just hours later that same day. Earlier this year, a magnitude 7.8 earthquake struck the Philippines. A pair of major earthquakes measuring 72 and 7.5 struck Venezuela, representing that country's strongest seismic activity since 1812, and a magnitude 7.3 struck Mexico in July. Even earlier this year, a magnitude 6.7 earthquake was recorded in the North Atlantic Ocean, roughly 1,860 miles northeast of Puerto Rico. An event large enough to be the second biggest earthquake recorded worldwide up to that point in the year, though, similar to this morning's South Atlantic event, it struck far enough from land that it posed no direct threat to anyone. That North Atlantic earthquake, initially estimated at magnitude 6.9 before being revised down to 6.7, occurred at a shallow depth of about 10 kilometers. In the U.S., National Tsunami Warning Center specifically confirmed that no tsunami was expected given the earthquake's location and the historical tsunami record for that stretch of ocean, a conclusion that closely mirrors what monitoring agencies have determined about this morning's South Atlantic event as well. Combined seismic energy released globally just within the current month has already reached levels equivalent to a single earthquake of roughly magnitude 8.2, according to ongoing global monitoring estimates, underscoring just how much total seismic activity the planet has produced within a very short window of time. To put that figure in perspective, the combined energy release is roughly equivalent to more than 2,000 atomic bombs of the size dropped during the Second World War, a genuinely staggering amount of energy, though it's important to understand that this total is spread across potentially thousands of individual earthquakes of every size, from the magnitude 7 disasters making international headlines down to the countless magnitude 2 and 3 tremors that occur constantly and imperceptibly across the globe. Still, when scientists add it all up and compare it against historical monthly and yearly totals, the picture that emerges for 2025 and 2026 combined is one of a planet releasing tectonic stress at a pace that stands out clearly against recent historical norms. None of this means that today's South Atlantic earthquake is somehow directly connected to the earthquakes striking Colombia, Indonesia, or anywhere else around the world this year, and responsible seismologists are always careful to avoid suggesting that kind of direct cross-continental causation without solid physical evidence to support it. Earthquakes separated by thousands of kilometers along entirely different, mechanically independent plate boundaries generally do not trigger one another in any simple, direct chain of cause and effect. The Scotia Plate's boundary with the South American and Antarctic plates operates according to its own local stress accumulation and release cycle, entirely independent of what's happening along the Nazca North Andes boundary beneath Colombia, or the Indo-Australian Eurasian boundary beneath Indonesia. But this morning's earthquake is a genuine, real-time data point within a broader global pattern that scientists continue to study closely, a pattern of persistently elevated seismic energy released distributed across multiple entirely separate tectonic boundaries around the world throughout 2025 and continuing into 2026. And every additional data point, even a remote and harmless one like this morning's event, contributes to the larger scientific picture researchers are working to understand. So why does an earthquake like this one, striking in a place with no people, no infrastructure, and no immediate danger to anyone, actually deserve attention at all? There are a few genuinely good reasons. First, remote earthquakes like this one play a critical role in how scientists study and understand plate tectonics more broadly. The Scotia Plate is one of the smallest and most structurally unusual tectonic plates on the planet, and every earthquake recorded along its boundaries adds another data point to scientists' understanding of exactly how it moves, how fast it's deforming, and how its unusual geometry, a large plate subducting beneath a small one, behaves differently from the more commonly studied subduction zones found elsewhere. Because so few people live anywhere near this plate boundary, and because so little infrastructure exists to study it directly on the ground, seismic monitoring from a distance using data recorded by instruments scattered across South America, Antarctica, and various remote research stations remains one of the primary tools scientists have for understanding how this genuinely unusual plate actually behaves over time. Second, earthquakes in this general region, while this particular one struck too far from land to pose any tsunami risk to populated areas, do occasionally generate tsunami waves that get monitored by tsunami warning centers as a matter of standard practice, precisely because the South Sandwich subduction zone is capable of producing significant undersea ruptures. Monitoring agencies routinely track events like this, one specifically to rule out any tsunami risk to South America, Southern Africa, or the scattered research stations and shipping routes that do operate in the surrounding waters, even when, as in this case, the ultimate conclusion is that no meaningful threat exists. This kind of routine monitoring and rapid assessment is exactly the same process that gets triggered by every significant earthquake, anywhere in the world's oceans. And it's worth understanding that the absence of a tsunami warning following an earthquake like this one isn't an oversight or a low priority response. It's the direct result of careful, real-time scientific assessment concluding that the specific characteristics of this earthquake, its location, its likely depth, and the historical behavior of this stretch of ocean simply didn't meet the threshold for tsunami risk. Third, and perhaps most broadly relevant for anyone following global seismic activity this year, earthquakes like this one are a useful reminder of just how constantly active our planet actually is, even in the places nobody is watching. More than 1,000 earthquakes occur somewhere on Earth within any given 24-hour period, the overwhelming majority of them too small to be felt by anyone, striking in oceans, remote wilderness, and sparsely populated regions far from any city. The earthquakes that make international headlines, the ones that devastate cities and kill hundreds or thousands of people, represent only a tiny fraction of the total seismic activity our planet produces on any given day. Today's South Atlantic earthquake is simply a more visible example, because of its relatively significant magnitude, of the ongoing, ceaseless tectonic activity that never actually stops anywhere on Earth, whether or not anyone is around to notice it. It's also worth understanding, for anyone who happens to be traveling through or working in this general region, exactly what the practical risk profile actually looks like. Antarctic research stations, particularly those situated along the Antarctic Peninsula closest to the Scotia Sea, do maintain seismic monitoring equipment as a standard part of their broader environmental monitoring programs, both for basic scientific research purposes and as a general safety precaution. Shipping routes that pass through the Drake Passage and the broader Scotia Sea, including cruise vessels that operate seasonal tourism routes toward Antarctica and South Georgia, along with commercial and research vessels, generally operate under standard maritime safety protocols that account for the region's known seismic activity, though an earthquake of this magnitude, occurring at this distance from any vessel or research station, would not be expected to pose any direct threat to shipping or to personnel stationed in the area. The South Sandwich Islands themselves remain uninhabited, aside from occasional visits by researchers and, on rare occasions, tourists aboard specialized expedition vessels, meaning there is genuinely no permanent population anywhere in the immediate vicinity of this morning's earthquake that would need to take any kind of protective action in response to it. Stepping back to the bigger picture, this morning's magnitude 6.2 earthquake in the Scotia Sea is a genuinely good illustration of an important distinction that's worth understanding. Whenever you see an earthquake headline pop up, the distinction between an earthquake's magnitude and its actual real-world impact. A magnitude 6.2 earthquake, striking in a densely populated area with old or poorly reinforced buildings, can be an absolutely devastating disaster, capable of killing dozens or even hundreds of people and destroying entire neighborhoods, as we've unfortunately seen demonstrated multiple times just this year alone in various parts of the world. That exact same magnitude 6.2 earthquake, striking 90 kilometers from the coast of Antarctica, an open ocean with no population anywhere nearby, produces essentially no impact at all beyond a data point in a seismic catalog and a brief mention in earthquake tracking reports. This is precisely why seismologists are always careful to emphasize that magnitude alone tells you very little about how dangerous or significant any given earthquake actually turns out to be. Location, depth, population density, and local building infrastructure all matter just as much, if not considerably more, than the raw number that ends up in a headline. An earthquake's true danger is never just a function of how much energy it releases, but of exactly where that energy happens to be released and who, if anyone, happens to be standing above it when it happens. For anyone following global seismic activity closely, whether out of genuine scientific curiosity or simply a desire to stay informed about what's happening on our planet, earthquakes like this morning's South Atlantic event serve a genuinely useful purpose beyond their immediate limited local impact. They're a reminder that the Earth's crust is in a constant, never-ending state of motion, releasing accumulated tectonic stress along plate boundaries scattered across every ocean and every continent, whether or not those boundaries happen to run beneath a major city. The Scotia Plate, tucked away in one of the most remote and least visited corners of the entire planet, continues its slow, complex dance between the South American and Antarctic plates, generating earthquakes with a steady, well-documented regularity that most of the world will simply never hear about, precisely because there's nobody there for it to directly affect. And yet, understanding this plate, and plates like it scattered around the globe in similarly remote corners of the ocean, remains genuinely important scientific work. Because the same fundamental physics governing how the tiny, obscure Scotia Plate moves and ruptures also governs how the much larger, much more dangerous plates beneath places like California, Japan, and Indonesia behave, making every earthquake anywhere on the planet, no matter how remote, a small but genuine contribution to humanity's broader understanding of the forces shaping the ground beneath all of us. As of right now, there are no reports of any damage, injuries, or tsunami threat connected to this morning's magnitude 6.2 earthquake, consistent with what would be expected for an event of this magnitude, striking such a remote and unpopulated stretch of ocean. Monitoring agencies continue tracking seismic activity across the broader South Atlantic and Scotia Sea region as part of their standard, ongoing global earthquake monitoring operations, watching for any further activity along this genuinely unique tectonic boundary in the days ahead. And beneath the cold, remote waters separating South America from Antarctica, the Scotia Plate continues its slow, steady, largely unnoticed work, grinding against its neighboring plates in a tectonic dance that has been unfolding for tens of millions of years and will continue producing earthquakes here at the same steady pace for millions of years still to come, almost entirely unnoticed by the rest of the world. If breakdowns like this one, covering the earthquakes that never make it into mainstream headlines but still matter for understanding how our planet actually works, are useful to you, take a moment to like this video and subscribe, because there is genuine value in understanding not just the earthquakes that devastate cities, but the quiet, constant seismic activity happening in places most people never think about. Leave a comment with your thoughts below, especially if you've ever traveled through or worked in the Antarctic or subantarctic region, because first-hand perspective on a place this remote genuinely adds something valuable to a conversation like this one. And if you know anyone with a general interest in geology, tectonics, or Antarctic science, share this with them, because the Scotia Plate remains one of the most genuinely underappreciated and scientifically interesting tectonic features on the entire planet. A magnitude 6.2 earthquake struck the South Atlantic Ocean early this morning, 90 kilometers from Antarctica. And while almost nobody felt it and nobody was harmed by it, it stands as a quiet reminder that our planet's crust never actually stops moving. In every ocean, along every plate boundary, whether or not anyone happens to be watching. Stay informed and stay with us as we continue tracking seismic activity around the world in the days ahead.